What's up guys, and welcome to this video on question 1 of the 2018 IEB AP Maths exam. Okay, so this question really focuses on some absolute value stuff and lin rules, particularly your lin rules or your log rules. Okay, so let's get straight into the question. Question 1.1a. Okay, so question 1.1 says solve for x, where x is a real number or element of the reals, without using a calculator and show all working. Okay, so remember, we're starting with the absolute value of x squared plus x is equal to minus 2x minus 2. Okay, remember with absolute values, we have to take into account two scenarios. The first scenario is where we just drop the absolute value sign, and the second scenario is where we negate whatever is, we put a negative sign in front of the absolute value. So that means we have minus x squared minus x is equal to minus 2x minus 2. Okay, from here it's some simple algebra. So we have x squared plus 3x plus 2 is equal to 0, or taking negative x squared to the right hand side, we have x squared minus x minus 2 is equal to 0. Okay, let's factorize. So we have x and x is equal to 0, or x and x is equal to 0. So on this side, this should be quite easy for you guys, plus 1 and plus 2, and this is minus 2 and plus 1. Okay, so basically what we can say is that x is equal to minus 2, or x is equal to minus 1, or x is equal to 2, or x is equal to minus 1. Okay, so we have minus 1 coming out twice, that's no problem. Now remember, with absolute values, again, we need to do our check. So basically what we need to do is substitute each of these values, minus 2, minus 1, and 2, into this original expression and see if the left-hand side and the right-hand side are equal. I'll do it for one of them. I'm going to pick the case x is equal to 2. So for x equals 2, we have the left-hand side is equal to 2 squared plus 2, which is equal to 4 plus 2, which is 6. And the right-hand side is equal to minus 2 times 2 minus 2, which is equal to minus 6. So the left-hand side is not equal to the right-hand side. So x equals 2 is x cannot equal 2. It's not a solution. Okay, so what you guys can do, and you need to do this in the exam, is substitute x equals minus 2 and x equals minus 1, and you actually get that those two are valid solutions. So therefore the answer is x is equal to minus 2 or x is equal to minus 1. Okay, but that's the importance of doing the check. Sometimes solutions are not valid. Okay, so let's move on to question B, which says ln x cubed plus 2 ln x squared is equal to 7. So we have ln x cubed plus 2 ln x squared is equal to 7. So we've got to use some ln rules. So the first rule is I'm going to take that 2 inside, so then we put it in the exponent, so that's going to be x squared times 2, which is x to the 4, is equal to 7. Then what I'm going to do is, using ln rules again, the plus becomes a multiplier, so it's x cubed times x to the 4, which is equal to x to the 7, is equal to 7. Then I'm going to undo the exact same rule that I took place here, so now I have 7 ln x is equal to 7, so ln x is equal to 1. I'm going to raise everything to the power of e, so ln x, e to the ln x is equal to x is equal to e to the 1, so that means that x is equal to e. And that is the final solution, and in total there we got 8 marks and 6 marks, so 14 marks in total. Okay, so question 1.2 says the equation for radioactive decay of a radioactive element is y is equal to y naught e to the power of minus kt, where k is greater than 0. Okay, and y naught is the initial amount, y is the amount after a given period of time, and k is a constant. The half-life of an element is the time taken for half of the quantity to decay. So y half-life is equal to 0.5 times y naught. Okay, so it's the amount of time for half of the initial value to come out. So question A says make k the subject of the formula. Okay, so we're going to start off with y is equal to y naught e to the minus kt. Okay, I'm just going to rearrange this initially. So I'm going to say e to the minus kt is equal to y over y naught. I'm going to ln both sides, so I'm left with I'm left with minus kt is equal to ln y over y naught. So I want to solve for k as my subject. So k is going to be equal to minus ln of y over y naught divided by t. Okay, and that is my final answer, and we get a nice 4 marks for that. Okay, part B says determine the value of k for carbon-14 if the half-life of carbon-14 is equal to 5,700 years. So T is equal to 5,700 years. And my y is equal to my y half-life, which is equal to 0.5 y naught. Give the answer to 6 decimal places. Okay, so I'm solving for k. So k is going to be equal to minus ln. My y is now replaced by my y for my half-life, which is 0.5 y naught, divided by y naught over t, which was 5,700. So this is equal to minus ln of 0.5 divided by 5,700, and if we plug that into our calculator, we get a value of approximately 1,216 times 10 to the minus 4. So that's our value for k. Okay, so part C says how old is a sample in which 10% of the carbon-14 nuclei originally present. How old is a sample in which 10% of carbon-14 nuclei originally present have decayed? In other words, 90% of the original quantity remains. Okay, remember we defined y as the amount left after time t. So this means that the y for this scenario is there's 90% left, so there's 0.9 y naught left. Okay, so we want to solve for t. So the first thing I am going to do is make t the subject of my formula. So from, let's say, equation star. So from star, we get that t is equal to minus ln y over y naught over k, which is equal to minus ln, and I replaced y with 0.9 y naught over y naught, and I'm going to leave k as it is for now, so that's equal to minus ln of 0.9 divided by my value of k, which I calculated before, and we get that t is equal to approximately 866 years. Okay, so really nothing too difficult, nothing too difficult. We get 4 marks, and in total we get 24 marks. So a nice question, nice and easy. You need to know your absolute value stuff, as well as your ln and log rules. So yeah, thanks for watching, guys. I hope you found this useful.